We need to derive units for Rydberg constant RH. If you want to derive units for Rydberg constant, we must know the formula in which it is included. In which formula Rydberg constant is included? In spectral formula. That is 1 by lambda equals to RH 1 by nf square minus ni square. I'll arrange these fundamental quantities. Where can you use this formula? When an electron jumps from initial state to final state, it releases a photon or either it absorbs a photon. This lambda is the wavelength of that photon. Lambda is wavelength. This nf and ni are quantum numbers, principal quantum numbers for those two states. This nf and ni, they don't have any units because they are quantum numbers, just numbers. So they don't have any units. So if you can find unit for wavelength, you can get units for RH. Lambda is wavelength, right? It's length, wavelength. So obviously SI unit is meter. But we want for 1 by lambda. Then it will become 1 by m or meter power minus 1. If you substitute this value here, m power minus 1, then we will get the value for RH, SI unit for RH. This is SI unit for RH. Let's see another quantity, Planck's constant. SI units of Planck's constant are units of Planck's constant. If you want to know the units of Planck's constant, we must know the formula in which it is included. In which H is included? H includes in so many formulas, but we need a simple formula, that is energy of photon. E equals to h nu. Here E is energy, H is Planck's constant, nu is frequency. We need energy and frequency units so that we can find units of H. What are the units of energy? Any kind of energy have similar units, same units, either energy of photon or kinetic energy or potential energy or spring energy. Any kind of energy have same units. So I'll take kinetic energy as an example because it's easy to derive of mv square. M is the mass, v is the velocity. SI unit of mass is kg. SI unit of velocity is meter per second, meter by second whole square. Then it will become kg meter square second power minus 2. These are the units of energy. What are the units of frequency? If you want to write the units of frequency, we must know the formula. Frequency is 1 by time period, right? That means 1 by second, because time period measured in seconds. It will become second power minus 1. If you substitute these two values in this formula, we can get for H. Substitute these two values here. Kg meter square second power minus 2 SI units of H times second power minus 1. Frequency is second power. Send this second power minus 1 this side. Here these two are multiplying. If I send this side, it will divide this quantity. Cut these two. Finally, we left with SI units of H, kg meter square S power minus 1. Let's see another quantity. Magnetic energy density. What is this density? We have so many densities: energy density, mass density, population density, particle density. What does energy density means? Energy density means energy contained in particular volume. Mass density means amount of mass contained in particular volume. Similarly, particle density means number of particles in particular volume. Energy density means ED means energy density equals to energy divided by volume. Remember this. We already know SI units of energy, that is kg meter square second power minus 2. We derived from kinetic energy. Volume is length into breadth into height, right? Volume of a cuboid. You can take any volume, either volume of sphere, cube, cuboid, anything. SI unit of length is meter, breadth is also a length meter, height is also a length meter. So volume units are meter cube. So I'll substitute here. If I simplify this, finally I left with kg meter per minus 1 second per minus 2. These are the SI units of energy density, magnetic energy density.